This tutorial picks up where the previous one left off, so I recommend starting with that one before you go into this one. But you can also just do the first few steps of the first part to set up the render, the camera, the light, and then skip to part 2 if you want. In part 2, we'll be discussing assigning UVs to a surface and using them with textures in materials. We'll be covering a few other approaches in follow-up videos. We'll be using version 0.23, so make sure you're using at least that version. There's a download link in the video description. In the previous part, we used an SDF that had built-in support for the UV attribute. But many SDFs don't have that support, and for those cases, we can assign UVs using several different types of layouts. So we're going to create a 3D SDF by revolving a 2D cross-section around an axis. First, we're going to insert a null dat between the SDF from the previous section and the renderer. This will make it easier to switch that out. Open the palette using the Alt-R shortcut and create a rounded rectangle SDF 2D. Then create a revolve and connect that to the rounded rectangle SDF. Then connect the revolve to the null dat that we created so that it is now connected to the renderer. Set the axis on the revolve to Y, and then set the radial offset to 1.5, and that will give us kind of a hollow pipe shape. Then on the rectangle, we're going to set the scale to 0.4 and 2, and then we're going to set the rounding to 0.2, 0.2, and then 0 and 0. So that'll give us a rounded edge on the outside here, and then a hard edge on the inside. Now that we've got our surface set up, we're going to add a material. Open the palette again and create a modular material. And insert that between the revolve and the null. Then, with the modular mat selected and nothing else selected, use the Alt-Shift-R shortcut to open the Editor Tools menu, and then choose Add Specular. This will create a specular shading element and connect it to the material. I'm going to set the method to Gaussian and set the shininess to 0.7. Then select the material again and make sure nothing else is selected, and open the Editor Tools again and choose Add Diffuse. So this will create a diffuse shading element similarly and attach it to the material. Set the method to Oren-Nair and the roughness to 1 and albedo to 0.7. Create a texture field, and like in the previous tutorial, make sure to use texture field and not texture 3D field. And that's because even though we are working in a kind of three-dimensional context, the texture that we're dealing with is two-dimensional. Create a movie file in top and select an image. Then add a null top to the end and drag that onto the texture parameter of the texture field. So like in the previous section, we're going to multiply the diffuse shading with the color from the texture. So select the diffuse shading element and the texture field, and open the editor tools again and choose Combine Fields and Multiply. This will create a Combine Fields operator set to multiply connected to both of those. Then we're going to connect this to the material instead of connecting the diffuse directly. So remember from the previous part that the default behavior of texture field is to project the texture along the XY plane centered at the origin. So you can try adjusting the translate parameters here and see how it's moving just kind of on the XY plane as though it was coming out of a projector and not actually following the shape of the surface. In order to be able to fit the texture to the surface, we need to set up UV coordinates that fit the shape. In the previous section, we were able to do that using the built-in UV support in the Torus SDF. But the SDF that we've set up here doesn't have that, though hopefully in future versions it will be more widely supported in the toolkit. Instead, we're going to create an assign UV and insert that between the revolve and the material. Then select the material and open the editor tools again, and under reference variable, choose surface UV. So this gets us a variable reference to the UV attribute that can be used with any of the elements that are being combined into the shape, into the material to get the color. So anything connected to the inputs after the first one. So we're going to connect the surface UV to the UV map input on the texture field. So you won't see a visible difference yet, and that's because by default, assign UV just uses the X, Y, Z coordinates, which is the same as the default behavior of the texture field. To make things a little bit easier to see, we're going to increase the scale on this to say 3 and 3. So you can see it's still kind of projecting onto this plane. So if you move it to the side, it doesn't quite fit. So on the assign UV, we're going to pick a UV mode that fits the shape that we're working with. So in this case, cylindrical Y is appropriate since we're dealing with kind of a cylinder-like shape. And now if you adjust the translate on the texture, you'll notice how it's kind of wrapping around the surface, and you can see it a little bit there in the back when it wraps around. So in order to get this texture to fill the space, even outside the 0 to 1 coordinate range, we're going to set the extend mode to mirror. You can also use repeat if you want, and that will kind of fill out all of the different places that the texture is used. In the previous tutorial, we demonstrated one example of how transform operators in some cases don't change the UVs. So here we're going to create a rotate operator, and we're going to insert that before the assign UV between the revolve and the assign. So if you adjust the rotation here, you'll notice that the UV coordinates kind of stay fixed in space and they don't move with the shape. And that's because the calculation that is done to come up with those UVs is happening after the shape has been rotated. So the assign UV doesn't know what this shape is. It doesn't really have any sense of its dimensions or layout. So it's just treating space as a cylinder, and that cylinder sits in place regardless of what the input to it is. So if you move the rotate after the assign UV, then you'll notice that the UV coordinates move with the shape. And that's because at the point when this is coming up with the UV coordinates, it hasn't yet been rotated. So the rotation happens after that calculation. But what if we want to move only the UVs and not the shape? So create a UV transform, and we're going to insert that instead of the rotate here. And we can delete the rotate. So now on the UV transform, try adjusting the translate parameter and rotate, and notice how it's kind of transforming the UV coordinates without actually moving the shape itself. And you'll notice that the z-axis doesn't do anything, and that's because we're still dealing with a two-dimensional texture that doesn't have a z coordinate. Now, if you try using rotate, you'll notice that things are kind of moving in a different way than one might anticipate, and that's because we're moving sort of a cylindrical coordinate system and not, position like X, Y, Z positions that were calculated using a cylinder. It's rotation and other operations might behave a little differently than you expect. So to add some animation to this, on the UV transform, make sure that's selected and nothing else is, open editor tools, and under animate speed, we're going to choose rotate, and we're going to do the all three parts of that and not just one of the axes. And because we're dealing with degrees of rotation, we want values that are in a larger range, so I'm going to set the value multiplier for all axes to 30. And then you can adjust the speed of any of these. And you can also do something similar to animate the translate parameter there. Now in that case, because we're not dealing with degrees, then we don't need to change that value multiplier. But especially if you are using animating the translate parameter, you're going to want to make sure that the extend mode on the texture is set to either repeat or mirror, so that the texture doesn't get kind of completely moved off the surface and disappear. And that's it for the second part of this series. To recap, we're creating a 3D SDF using a 2D cross-section that's being revolved around the y-axis. We're then assigning UV coordinates to it using a cylindrical pattern also on the y-axis. We're then transforming the UV coordinates using a UV transform here. We added some animation using a speed generator there. We're then assigning a material to it, and within that material, we've got a specular shading element, and then we have a diffuse shading element, which we are multiplying with the texture field. And the texture's UV map input is using a variable reference that came from the material for the surface UV attribute. Working with assigned UVs like this can be difficult depending on the shape that you're using. In this case, we were using something that's roughly cylindrical, so it fit well with the cylindrical UV layout, but that won't always be appropriate for all shapes. Determining UVs for surfaces can be a lot more complicated than one might think. Remember that in ray marching, there are no vertices or points, and there isn't even really a surface like there is with SOPs. Instead, there's a mathematical formula that describes the shape. That means that in order to get UVs to fit the shape, we need another formula that describes the layout of the surface of that shape. If you find an example of a ray marching shader that uses textures on some type of SDF that doesn't support them in RayTK, or if you come up with a formula yourself, please reach out to me and let me know, and I'll see if I can add it to the toolkit. In upcoming videos, we'll go through some other approaches, including working with textures outside the context of materials. Check out my Patreon for more subscriber-only content like scene files, more tutorials, early access to features and tutorials, and more things like that. As always, feel free to reach out on the Touch Designer Discord or on Instagram if you have any questions. There are links to all those things in the video description. Thanks for watching, and stay tuned for the rest of the series.